This is Geometry Unit 3, Lesson 11 on coordinate geometry proofs. In order to do a coordinate geometry proofs, we have to know what formula to use when. So let's review. To prove two segments are congruent, what do we have to show? We have to show that they have the same distance or length. So if two segments are congruent, we have to use the distance formula to figure out the length. If we wanted to prove two segments are parallel, what do we have to show? Well, we have to show that they have the same slope. So we'd have to use the slope formula. So using the slope formula, find the slopes of each segment, see if they're the same. To prove two segments are perpendicular, what do we have to show? Well, we have to show they have opposite reciprocal slopes. So we have to use the slope formula again and see if the slopes are opposite reciprocals. And the last one, to prove that two segments bisect each other, you have to show they have the same midpoint. And the midpoint formula is finding the average of the coordinates. So you have to know the distance formula, the slope formula, and the midpoint formula in order to do a coordinate proof. So let's see how these apply to a problem. Quadrilateral ORCA has vertices of O00, R25, C11,8, and A93. And we want to prove that ORCA is a parallelogram. Now it's very helpful when you have a problem like this to have this graph so that you can see what you're doing. So let's graph this. 0, 0 would be here, that's point O. R would be at 2, 5. 1, 2, 1, 2, 3, 4, 5. There's R. C is at 11, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oops, 11, 8, sorry. 1, 2, 3, 4, 5, 6, 7, 8. There's C. And then A is at 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. So I want to connect my points so that I can see that this is I can prove this is a parallelogram or not. So here's my points, O, R, C, A. Okay, so we have to decide if this is a parallelogram or not. So how do we know a parallelogram is a parallelogram? Well, the reason it's called a parallelogram is it has two pairs of opposite sides parallel. So a parallelogram has both pairs of opposite sides parallel. Okay, so we have to prove that both pairs of opposite sides are parallel. What formula do we have to use to prove parallel? Well, we have to use slope. So we have to use the slope formula. So m is equal to delta y over delta x. So I need to find the slopes of the opposite sides. So let's do the slope of OR. All right, so I'm going to say the slope of OR using the coordinates O and R. My formula is delta y over delta x, 5 minus 0 over 2 minus 0. So that's going to be a slope of 5 over 2. What other side do I have to see if it's parallel to? Well, OR, the opposite side would be AC. So the slope of AC is, using A and C, these 2 points right here, 3 minus 8 over 9 minus 11. 3 minus 8 is negative 5. 9 minus 11 is negative 2. Negative 5 divided by negative 2 is 5 over 2. So, what do we know about OR and AC? They're parallel. OR is parallel to AC because, you have to write the because, they have the same slope. So now we have one pair of opposite sides parallel. OR and AC are parallel. Now we have to do the other two sides. So let's do the slope of RC. Make sure you're using the correct set of coordinates, R and C. R and C are here. So your slope is going to be 8 minus 5 over 11 minus 2. 8 minus 5 is 3, 11 minus 2 is 9, 3 over 9 is 1/3. and the slope of my parallel line to that would be OA. Using the coordinates O and A, it would be 3 minus 0 over 9 minus 0 is 3 over 9, which is 1/3. So what does that tell me about RC and OA? They're also parallel. RC is parallel to OA because they have the same slope. Now, we need to prove that this is a parallelogram. We said to prove the parallelogram, both pairs of opposite sides are parallel. So, is ORCA a parallelogram? We have to conclude that it is. ORCA is a parallelogram because both pairs of opposite sides are parallel. So that is my first coordinate proof. I proved this, I did the work, I used the slope formula to prove parallel, I explained why I used the slope formula, and then I concluded based on the work that I did why this is true. So, let's continue. We have proved now that this is a parallelogram, these two sides are parallel, and these two sides are parallel. Now, we also want to prove that ORCA is not a rectangle. Well, what do you know about rectangles? Well, what's special about rectangles is rectangles have what kind of angles? They have right angles. How do you get right angles? Well, you need perpendicular lines. So all we have to do is prove that one of these angles is not a right angle by proving that the lines are not perpendicular. Now, how do we prove lines are perpendicular? Our segments are perpendicular. We prove they have opposite reciprocal slopes. Well, we already did the slopes up here, didn't we? All right, let's pick an angle. Let's say we're looking at angle O. Here's angle O right here. What two segments make up angle O? Well, it's OR and OA. So, copying the slopes from up here, the slope of OR that we already did was 5 over 2. And the slope of OA, this one right here, is 1/3. Are these opposite reciprocals? No, they're not. So we would say OR is not perpendicular to OA because they do not have opposite reciprocal slopes. Yes, you have to write that out. Now, if they're not opposite reciprocal slopes, they're not perpendicular, what is not a right angle? So, angle O is not a right angle. So, ORCA is not a rectangle because it doesn't have a right angle. So that is the proof that we had. So we had to use the slope formula to do that. All right, the third thing that we want to prove is that the diagonals of ORCA bisect each other. So, if we want the diagonals to bisect each other, all right, we have to know where they are. So if I look at my picture here, if I draw my diagonals, I would draw in my line from O to C and from R to A. Okay, so how do we know if the diagonals bisect each other? What should happen? They should have the same midpoint. The diagonals would have the same midpoint. Let's see if they do. The same midpoint. So we need the midpoint formula. We have to find the midpoint of the diagonals. So the midpoint formula, remember, is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So the midpoint of OC, that's my first diagonal, that would be this one right here. We have to use the coordinates of O and C, add them together. So the x's add up to 0 plus 11 divided by 2 for the x, and then 0 plus 8 divided by 2 for the y. So this is going to give me 11 over 2 and 8 over 2, which is 5.5 and 4. So the midpoint of OC is at 5.54. Now, let's find the midpoint of the other diagonal. The other diagonal is RA. All right, using my coordinates, make sure that you use R and A here. So the coordinates of R and A here are 2, 5, and 9, 3. So we have 2 plus 9 divided by 2 for the x's, and then 5 plus 3 divided by 2 for the y's. All right, 2 plus 9 is 11 over 2. 5 plus 3 is 8 over 2, which actually works out nicely again to be 5.54. So, do the diagonals of ORCA bisect each other? The diagonals of ORCA bisect each other because they have the same midpoint. The diagonals of ORCA have the same midpoint. So, they bisect each other. And we have proved that. Again, I did the work, I explained why I did it, and wrote a concluding statement. So, when you do a coordinate proof, it's very important. Show your work, tell why you're doing it, and conclude why your statement is following is true. So that is an example of a coordinate geometry proof. We'll be doing some more of these in class.